Hello and welcome. My name is Dan Nato, Application Engineer here at Saratech. Today I'm going to give a quick video of Simcenter 3D inside of Teamcenter. So here's a basic file structure for a single finite element model outside of Teamcenter. So you're going to have your master part. From there, you're going to create a new FEM and SIM, as shown over here on the right. And from here, it creates an idealized part, a FEM part, and a SIM part. Inside Teamcenter, your part file is called an item. Your idealized part is called CAE geometry. Your FEM part is called a CAE model. Your SIM part is called a CAE analysis. And I tried to show the file structure over here on the right. That's showing that your SIM part is referenced to your FEM part's referenced to your idealized part, and your idealized part's referenced to your physical part. If you go ahead and set up an analysis inside of Simcenter 3D in this managed environment, and you go ahead and solve your solution and you hit save, it's going to ask you to import files for this entity inside of Teamcenter. Things like would be the input deck, your results file, FO6 file, log file, etc. Now when you go ahead and save these files into Teamcenter, they're listed under name references under the SIM file dataset. So right click on this SIM file dataset, name references, and right here is the list of the entities that were saved in. And you'll see that in this case I saved in the OP2 file, the FO6 file, the log file, the DAT file, etc. Now it might make sense to not include some of these files, so it's up to you what files you want to include. One thing that you can also save is a results JT file. So you can generate the JT file by right-clicking on your solution inside Simcenter 3D, hit New Results JT file, and with this JT file, you can post-process that part without having to import the OP2 file into Teamcenter. So using a JT editor, you can go ahead and review those results. So let's go through a quick demonstration inside Teamcenter. So just to review what I showed, and I have one of these set up, I created a folder, and you'll see that I have my part, my FEM, my SIM, and my idealized part rolled up in here. And if I expand my SIM part, you'll notice that I have my SIM, and that will reference down to my FEM and continue down. But as I mentioned, if you right click here on the SIM dataset, I can go to name references, and this is where you'll be able to find your files that you save back in. So in this case, I saved in such as the DAT file, the FO4, FO6 log file, etc. So in our case, let's go ahead and create a new model. So I'm going to say File, New. I'll put it in a folder, and we'll just call it Test Folder. And I'll put Dan. That way I can find it. All right. So here's my test folder Dan, got it created. So let's go ahead and just launch NX. Now for this example, it might take a little bit. I'm running this on a virtual machine. And it's sending it to the application where we're going to go ahead and create our part file. And then from part file, we're going to create our simulation entities, such as our idealized part, our FEM part, and our SIM part. And this should take a moment. And it looks like NX is opening. So from here, we're going to go ahead and create a new part. So I'm just going to say File, New, and I'm going to create that new item. And then from here, I'm specifying my units. I'm going to do inches. I'm going to do a model. I'm just going to double click and give these whatever name that they have here. And I'm going to put it in that folder that I defined just to help organize these entities. So I called that test folder Dan. Let's make sure that we put it in the folder. There we go. Hit OK. And it's going to go ahead and give it an ID of 606 revision A with that name of 606. It's going to go ahead and launch that model. Just for simplicity, I'm just going to do a simple model here. Just going to give it a simple flat plate to make this quick and easy to set up, model, and solve. Create a simple extrusion. And in this case, I'm just going to draw a rectangle. And I'm not going to be too concerned about the size. And I'm just going to give it a value of 0 for the distance at this point in time, and I'll just assign thickness to it. So now to application PrePost, and this will launch it into our PrePost environment. And once we access our PrePost environment, we can create our new FEM and simulation. So here, it's going to ask us right away for our FEM. We're just going to assign it a simple ID name revision. It's going to go in our folder. So this is our FEM, and you'll see it's called a CAE mesh. There we go. And now you see the new FEM. It's CAD, it's associated to the master part, and we'd like to create our idealized part here. So now it's going to create an idealized part, which is our CAE geometry. And we'll hit OK. And then now it's asking us to create our CAE solution or our simulation part here. We'll just go ahead and hit OK. And you'll notice it's filling it out down here in our simulation file view. We have our part, idealized part, our FEM part, and our sim part. And we can just go ahead and associate this to the FEM, you'll notice. So make sure that everything is continually associative as well. And for this, we're going to keep 101 linear static sensor solution. All right. So if we needed to make any changes to the geometry, we could go to our idealized part and make any local changes. For this case, let's just go ahead and mesh our part. We're going to put a 2D tetrahedral mesh. We're going to put it in a mesh collector that we define, and we're just going to give this a value of 0.01 inches, and we're going to make this out of an aluminum, so we'll use 6061 for this case. All right, so now I have my collector defined, and let's go ahead and mesh this. Usually use this element size that's specified using the automatic element sizer. And we're just throwing a simple mesh on this structure. Next, we can go to our sim part. We can apply our constraints and loads. So I'm just going to do a simple cantilever beam here. Let's go ahead and specify these nodes. So we're going to fix it on one side, and we're just going to push down on it on the other. So we'll apply a force. We'll grab these nodes over here, and we'll apply 10 pounds. And we'll say in the Y sub C. Now we have our loads, our constraints. We can go ahead and solve our model. Just quickly hit solve. Watch things go back generated into Teamcenter if we wanted to review them. And like I said, it'll take a moment since we are working on a virtual machine. Let's get in there. Good. So now we can go back into Teamcenter, and you'll see that I have my part, my sim, my FEM, and my idealized part. And if I expand that sim, you'll notice if I right click and I say name references, I do not have anything related to Nastran at this time. Alright, so I have my solution, I have my loads and constraints, so I can go ahead and solve this solution. So I'm just going to right click and hit solve. And it's going to go ahead and send this to a Nastran solver, and it should take a moment just because it's such a small model. Launching the solver directly from the PrePost environment, and it's going to go ahead and finish and read in our results directly into Simcenter 3D here. So we can go ahead and review our results, and maybe interested in just looking at displacements. Does it make sense? Yes. Any other model checks we could do here. So as I mentioned, you can right click on your solution here, and you can hit this JT results file. And with this JT results file, you can specify the type that you're interested. You see, I have based on what I specified as an output request. So displacements, stress, etc. So I'm just going to say displacement nodal. Give me all 3 components. And now I have, as shown over here, available as a results JT file. And I can save that into native or managed. I have the data set name. Just call this displacements. I'll just keep it as default, but I'm in this manage environment. Hit OK. And now it went ahead and it created that results JT file that I can review inside of Teamcenter. So go under our sim. I have to save the file, I'm sorry. So if I go ahead and hit save, it's going to go ahead and save that back in. And you'll notice here, it's going to ask me which files do I want to bring in. So in this case, I'm just going to say the DAT file, the FO6, and log file. We'll grab FO4's file. So these are the files that I want to import in. So I can hit import selected files, and these files will be read into the Teamcenter environment. So now when I go back into Teamcenter, you notice I have my dataset JT. You can review this if you launch like a lifecycle visualization in my case. I'm just going to go ahead and hit that a while. And you'll notice that if I go to my sim now, you can see the results here. And if I right click, I can say named references. And this is where those informations are stored. So you'll see I have my FO4, FO6, and log file directly there inside of Teamcenter. So that is where those files are located. And I'm launching this Visualization Pro in my case. It doesn't work that well because I am using this virtual machine. It doesn't have its graphics card. But if I wanted to review, I could rotate the model and things like that. But I do have a scale, and I can interrogate the model a little bit using this data, this JT data. So just to recap, inside a Teamcenter, you have your file, your sim, your fem, your idealized part, and the results information from the sim file or your Nastran files are stored under your simulation data set under your named references.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.